On the morning of 3 June 1998, a German family, after drinking coffee, was enjoying their train journey. This high-speed train was going from Munich to Hamburg. It was around 10:30 in the morning and everything was normal so far. But just 12 minutes later, that family became terrified when suddenly a piece of steel came out tearing through the floor beneath their feet. That too right between their seats. But this was just the beginning of the most dangerous accident in the history of German high-speed trains. Welcome once again to Dark Reality Videos. In the late 1950s, Japan surprised the world when their Shinkansen, meaning bullet train, became the world's first high-speed train. This train connected the cities of the entire country and made travel so fast that hours-long journeys turned into minutes. Following Japan, France and Italy also built their high-speed train infrastructure, and Germany was not left behind. Germany started its own high-speed train project named ICE, meaning Intercity Express. When these trains appeared in the 1980s, the world thought this was the future of trains. These trains had everything one could imagine: aerodynamic design, use of modern computers, and extremely comfortable travel. Everything seemed perfect. But every perfect system has a hidden weakness, and the weakness of ICE trains was their wheels. The first generation ICE trains initially had monoblock wheel design. That means the entire wheel was made from a single solid piece of steel, which was strong, cheap, and reliable. But a problem was noticed in these monoblock wheels. After some years, passengers started complaining that when the train ran at high speed, there was a strange vibration. In the buffet car, glasses, spoons, and forks started making noise due to vibrations. These vibrations made the journey unpleasant. When engineers checked, the problem was inside the wheels. Although monoblock wheels were made in one piece and were evenly balanced, even a small increase of a few grams on one side could create vibrations at high RPM. And this is exactly what was happening. Due to high speed, friction wore out some parts of the wheels unevenly, disturbing the balance. At low speed it was not noticeable, but at high speed, the entire train started vibrating. This is a common problem with any wheel. Even in cars, if extra weight is added on one side, it can cause vibration at high speed. To fix this, wheel balancing is done by adding weight on the opposite side. But balancing a large number of train wheels is very difficult, especially when they are made in one piece. Replacing wheels is also difficult and expensive. So German engineers came up with a new solution called resilient wheels. These were not one piece. The inner ring and outer ring were separate, with a rubber layer between them to absorb vibrations. This design allowed only the worn outer part to be replaced instead of the whole wheel. This design was already used in German trams, but trams ran at low speed, while ICE trains ran at very high speed. This was a major issue that was ignored. Executives approved the design without proper testing. And in the early 1990s, these wheels were installed on all high-speed trains. For a few years, everything worked fine. But later, a tram company in Hanover discovered cracks in their wheels. They replaced the damaged parts and informed Deutsche Bahn, the national railway company of Germany. However, since there were no vibration complaints in ICE trains, the warning was ignored. Exactly 1 year later, everything changed. In the morning, ICE train 884 left Hanover station for Hamburg. Inside were passengers and crew members. Everything was normal at departure. In coach number 1, a man named George Detman was traveling with his family. After some minutes, something hit the floor and suddenly a sharp steel piece came out between two seats. This was actually a broken piece of the wheel. George and his family panicked. If the metal had moved slightly left or right, they might not have survived. He immediately sent his family to another compartment and went to find the conductor. The conductor was in another coach. According to company policy, the train could not be stopped until the issue was confirmed. so they both went towards the first coach. Meanwhile, the train was still running at high speed and vibrations were increasing. By the time they reached, the train had traveled several kilometers and was approaching a dangerous section where tracks split. The broken wheel piece was still dragging under the train. As the train crossed the track switch, the metal hit the mechanism and changed the track alignment. Now the front coaches were on one track while another coach moved onto a different track. The train twisted, and one coach crashed into a concrete bridge pillar. This collision destroyed part of the bridge. Following coaches derailed, collided, and were crushed under falling concrete. Some coaches were flattened to just a few inches. Only the first two coaches survived, while the rest were destroyed. The locomotive stopped far ahead. The driver felt a shock but had no idea what had happened behind. The accident occurred near a small town. People rushed to the scene after hearing the explosion. What they saw was devastating: broken coaches, metal debris, fire, and people screaming. Many were trapped under debris or stuck inside due to strong pressure-proof windows. Rescue workers had to use heavy machinery, and it took hours to reach victims. Hundreds of rescue workers, ambulances, and doctors arrived. Nearby, a medical conference was taking place, and doctors also joined rescue efforts. But by then, it was too late. In this accident, more than 100 people died. Many were seriously injured, and many had minor injuries. Those in the first two coaches survived. This disaster shocked not only Germany but also countries with high-speed rail systems. Initially, investigators suspected an obstacle on the track, but when they saw the wheel fragment, the cause became clear. Records showed that the same wheel had issues reported multiple times but was never replaced. Crack detection machines existed, but inspections were still done manually. Warnings from research organizations and tram companies had also been ignored. Engineers later explained that the wheels rotated hundreds of thousands of times daily at high speed. This caused fatigue cracks that grew over time. The rubber layer absorbed vibrations, hiding the issue until it was too late. Finally, on that day, a single wheel failure caused one of the deadliest high-speed train accidents in history. After this disaster, all trains switched back to monoblock wheels. Safety improvements were made, including changes to infrastructure and emergency systems. Germany re-evaluated its entire railway system. Even today, this disaster is taught as a case study in railway training centers. Monoblock wheels may be more expensive and require maintenance, but they are safer at high speed. Hopefully, you liked this video from Dark Reality. Thank you for your support and comments. See you in the next video.